Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at Physical Sciences, Paper 1. This was in November 2019 exam paper for grade 12. So we'll be looking at a momentum. As you can see over there, I've tried to make a drawing which represents what we'll be doing for today. So there's a question paper that I posted in our Telegram group, where whoever joining this lesson is advised to quickly go to that question paper so that I'll read it out, interpret the given statement, and most importantly, go through that given diagram and again go through the questions, answer the questions, and most importantly, show you exactly where you score your marks. So I notice on the line, Nolene has joined. So Nolene, try to go to that question paper. So I'm going to quickly read through that given statement. Can you just confirm for me if you got that question paper? Are you able to see that question paper that I posted in the group?
Yes, sir.
100%. So the question reads as follows. A bullet moves east at a velocity of 480 meters per second. So with that statement alone, let me just quickly change the orientation so that I can easily zoom in and clearly see that given statement. So with that sentence alone, it says a bullet moves east at a velocity of 480 meters per second. So you need to know that compass. Obviously, we've got north, east, south, and west. So now they're saying the bullet moves to the east, which means it's moving in that direction at a velocity of 180 meters per second. So to interpret the speed, Nolene, it means for every second that bullet covers a distance of 480 meters. So that is what a speed means. So it means for every so for every second, 480 meters is covered. So this is just for your information to remind you of how fast this bullet is moving. It's moving at a very fast speed. So it's moving eastwards. Then let's continue. It hits a wooden block that is fixed to the floor. So that means we've got a floor. On that floor, we've got a wooden block. So it's a block made out of a wood. And that block is fixed to that floor over there, which means this wooden block, it's not moving, or it cannot easily be pushed such that it's going to move. But remember, we've got that bullet which is traveling at 480 meters per second. So since this wooden block is fixed, it means its velocity is 0 meters per second. Why? Because it is not moving. And for that reason, it means its velocity is equals to 0. Remember, this is moving in that direction. So let's continue. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 40 meters per second east, which means it takes a certain time for that bullet to pass through that wooden block. And they say it takes a time of 0.01 seconds for that bullet to pass through the wooden block which is fixed to the floor. So once it passes that bullet, it emerges on the other side of that wooden block at a speed of 80 meters per second. So that means with this bullet passing through that block, it lost some of its momentum or some of its speed as a result of obviously the friction or the impact it had with that wooden block. Most importantly, they said it is still moving towards the east or eastwards, towards the east initially or eastwards, and again after passing through the wooden block which is fixed, it emerges at 80 meters per second. So let's see the diagram below. So that was the last part of that statement. And again, they say ignore the effects of air resistance. So that means there is no air resistance, so there's no frictional force as a result of air. Remember, if that bullet is moving in that direction and there's a strong wind in the opposite direction, it's going to result in friction opposing that bullet. But normally when we deal with momentum, and again when we deal with vertical projectile motion, it's in most cases where we ignore the effects of air resistance. So now they say on the statement, consider the block bullet system as an isolated system. So they're saying consider the block bullet system as an isolated system. Very, very much important, ladies and gentlemen, that you fully understand or you are aware of what is meant by isolated system. So guys, obviously what I've drawn over there, it's a representation of the given statement that I've just read now. So obviously we know for a bullet which is moving in that direction, initially at a speed of 480 meters per second, it passes through that wooden block which is fixed at that floor. As it emerges on the other side, it's still moving in the same direction, but at a reduced speed of 80 meters per second. So this compass is just there to guide you in terms of which direction is east. Obviously, when you know east, you know at the top is north, bottom is south, on the left is west. So now, ladies and gentlemen, let's try to answer some of the questions. I'm going to quickly read through the first question, which says, explain what is meant by isolated system as used in physics. So guys, 4.1, it's what I'm giving you as a homework. Remember, for every homework that I give it to you guys, you need to give me a response via inbox. Do not send it in the group, because otherwise someone else is going to still send the same thing. So you need to explain what is meant by isolated system as used in physics. So it's more like you just need to explain what is isolated system. So remember guys, at all times, this type of questions where you need to either state, for example, Newton's first law, Newton's second or third law, isolated system, define momentum, whatever. These are the terms that you need to know by heart. At all times, make sure that you know them by heart, because you don't need to perform any calculations over there. That's why I'm giving you those as homework, so that in case if it comes again, then you remember that you've done something similar, or otherwise it was given to you as a homework. So guys, most importantly, uh, remember that homework, you need to send it via inbox. So now let's move to question, what is it? I think it's question 4.2. Then we'll be doing 4.2.1. So let me quickly check what is the question for 4.2.1. Okay, so they say the magnitude of the momentum of the bullet before it enters the block is 24 kg meters per second. That is the momentum, the magnitude of the momentum of the bullet before it enters the block. So guys, before I answer this question, did you understand everything that I've explained up to this point, or is there a part where you wish for me to re-explain or to explain it again differently?
We understand, sir.
Okay, 100%. So now let's move to question, what is it, 4.2.1, where they say calculate the mass of the bullet. And this question is allocated 3 marks. Remember, guys, in physical sciences, you score a mark for correct formula. For you to write down the correct formula, they give you a mark. For you to substitute correctly, they give you a mark. For you to write down the final answer with the correct SI unit, ladies and gentlemen, they give you a mark, which is an indication that for this type of a problem, which is allocated 3 marks, you just need to identify the correct formula, substitute correctly, punch on a calculator, and get an answer with the correct SI unit. So it means it's not that much of a complicated question, ladies and gentlemen. It shouldn't be that much difficult. Remember, ask yourself this question: what exactly does the question want you to calculate? In this case, they want you to calculate the mass. What does it mean? It means in the end, you must say mass is equals to something. Ladies and gentlemen, mass is measured in kilograms. So your final answer must be a mass in kilograms. If you give something else as your final answer, already, guys, you're not answering the question. So in the end, we must say mass is equals to something kilograms. And remember, in physical sciences, we've got what we call a vector quantity and a scalar quantity. A vector quantity is that quantity that has got the magnitude or the size. Remember, the size is actually the value. And again, it has a direction. A scalar quantity is that type of quantity which only has the size or a value, or otherwise you can use the word magnitude. Ladies and gentlemen, is there someone who wants to guess what type of a quantity is the mass? Is it a vector or is it a scalar? Okay, guys, so mass, it's a scalar quantity. Why? Because mass has got no direction. So quantities like mass, time, speed, what else? Distance. These quantities, ladies and gentlemen, they do not have direction. You can never have a 2 kg upwards. You can never have 2 kg to the east. You can never have 2 kg, ladies and gentlemen, to the right. Also, same with time. You can never have 2 hours north. You will never hear such a thing. Speed. You can never have 3 meters per second upwards. Remember, we've got a speed and a velocity. So a velocity is the one that has a direction, but speed, it's a scalar quantity, does not have direction. And again, distance is a scalar quantity. You can only have 2 centimeters, but a displacement, there's something called a displacement, which is almost the same thing as the speed. I mean, the distance. The difference is that a displacement is a vector quantity, which means you can have has eastwards, northwards, southwards, westwards, down. Infinity is a vector quantity, it's a magnitude in a direction. Ladies and gentlemen, what's so far? Does it make sense, or did I lose you guys with that explanation? Guys, are you still there?
Yes, sir.
Yeah.
Okay, so I'll just make an assumption that you do understand. Um, and now we can work towards solving the question. So remember, guys, question 4.2.1 says calculate the mass of the bullet. And just before that question, they gave you a statement to say the magnitude of the momentum of the bullet before it enters the block is 24. So remember, guys, there's that formula which says the sum of momentum before is equals to the sum of momentum after. So you can still use the same formula, ladies and gentlemen. Remember, they are saying the sum of the momentum before. What exactly are we summing? We are summing two objects, which is the momentum of the bullet and the momentum of the block. Let's see. We know momentum is P, so we're going to have momentum of the bullet. Let me say small letter B represents the bullet. Capital letter B represents the block. So which means this is the momentum of the bullet plus momentum of the block. It's equals to momentum of the bullet plus momentum of the block. But remember, guys, we need to differentiate between this side and that side. That's why we are going to say a momentum of the bullet, let's say initial instead of using before and after in this case, and say momentum of the bullet initial, momentum of the block initial, it's equals to momentum of the bullet final plus momentum of the block final. Let's further expand that formula. Remember, the formula is mv of the bullet initial plus mv of the block initial is equals to mv of the bullet initial plus mv of the block final. Sorry, there it also has to be final. So ladies and gentlemen, let's now substitute. What is the mass of the bullet initial? We do not know what is the mass of the bullet at the initial stage. Why? It's because the mass is exactly what we are calculating. So let's just write mass and V of the bullet initial and say plus. Remember guys, the mass of the block we do not know, but we know the velocity is 0, which means we can still say mass of that block multiplied by 0. There's no use for us to even write it because already 0 multiplied by the mass is 0. So instead of having to write it, let's not write it because we know it's 0 and say this is equals to momentum on the other side of the equal sign is the final momentum. We've expanded it. This is how it looks like. So we've got the mass of the bullet multiplied by velocity of the bullet final. We do not know what is the mass, ladies and gentlemen. Let us just write the mass and say V of the bullet final plus what is the mass of the block? We don't know. So we just write it as mass. What is the velocity? It's 0. Why is it 0? Because in the statement they said the mass of the block, no, not the mass, but they said the block is fixed at that floor, which means it's not moving, which means its velocity is equals to 0. So remember guys, there's no need for us to write that part because the velocity of the block is 0. So 0 multiplied by anything is equals to 0. So let's not even write it because already it's 0. But remember guys, if you are in exam, you can still write it or leave it as it is written. Then on your next step, you just ignore it and not write it at all. So in this case, I'm just trying to explain to you step by step so that you fully understand how we get to that equation. So that means mass of the bullet times velocity of the bullet initial is equals to a mass of the bullet V and again V of the bullet final. Remember guys, a momentum represented by P. Let me just try to get a different marker. So P represents the momentum, which is equals to mv. We know this is the formula that is there on the formula sheet. So remember, they said something, guys, just before that question. They said on the question paper below 4.1, the magnitude of the momentum of the bullet before it enters the block is 24 kilograms meters per second, which means the momentum before it's equals to 24 kilograms meters per second, which means you can say, guys, before I write or substitute that part, Did you understand everything that I've explained so far? And again, did that interpretation make sense to everyone?
Se go be re thoma nna go be re ntlhalosetse mo go thoma mo go thomang ka
Tswela pele Noli.
mo ga P mo ga momentum before the initial after formula ya ntho eno ya mo ya
Okay, so let me do this. Okay, no go kry-ile goreng o nyaka gore ke thome mo kae. Sum, it means you must add. So what are you adding? You add momentums on the initial scenario. Which is meters per second. This is the bullet approaching the wooden block. Second situation, that is when that bullet has actually passed that wooden block and it's moving at 80 meters per second. So that means when you talk about the sum of momentum initial, we are talking about this side. When we talk about the sum of momentum final, why are we saying the sum? Why are we saying the block and again the bullet? So that means is the bullet plus the block. Is the bullet or the block plus whichever one that you start with. It doesn't matter whether you say you've got the block plus the bullet or you've got the bullet plus the block. Doesn't matter whether you say you've got the block plus the bullet or the bullet plus the block. So now, when we formulate, I'm going to now remove all of this and say, when we formulate, you say, you expand that formula. You say a momentum, P represents the momentum. So it's the momentum of the bullet initial plus momentum of the block initial. So remember, I said small letter B represents the bullet, bigger letter represents, or capital letter represents the block. So this part, we just expanded that formula by including the two objects involved. It's equals to momentum or of the block, or otherwise, let's say of the bullet, just so that we remain constant or consistent. If we started with the block and say bullet, then we're going to have the block. But let's say block final plus momentum of the block final. So this is the bullet final. So we know from the formula sheet that momentum is equals to mv. This is the formula. So let's now further expand that P and write it as mass of the bullet multiplied by V of the bullet. Remember, this is the the bullet initial or at initial stage, plus mass of the block initial multiplied by V of the block initial is equals to, you just write the same still, of the bullet but final multiplied by V of the bullet final plus M capital letter B final multiplied by V capital letter B final. So Nolin, I'm not sure if up to this stage you understand. Does everything make sense so far?
Sense.
100%. So now, remember, the velocity of the block is 0 because the block is not moving. So now that the velocity of the block is 0, so it's going to make the whole of this 0. It doesn't matter whether the mass of the block is 1,000 or is 2 or is whatever the mass it is, but because it's 0, then it means its momentum is 0. Therefore, you remain with just that, which is m, let's say, multiplied by v. This is the bullet initial. Then it's equals to. Same thing on this side. Velocity is 0. So it's not like after that bullet passes through that block, then that block moves. It doesn't move. It remains fixed in that position. So that means even on this side, the whole of that is 0. Then you just remain with that, which is mass of the bullet multiplied by v of the bullet on the final side. So remember, I've just said before we read that question, there's a statement where they say the momentum of the bullet before is 24 kilograms meters per second. Let me quickly check to verify. Yes, the magnitude of the momentum of the bullet before it enters the block is 24 kilograms meters per second. So remember, the whole of this thing, mv is momentum, and this is momentum of the bullet, of which they say is 24 kilograms meters per second. Then this is equals to what is the mass of the bullet? We do not know. This is exactly what we are calculating. So we can just write it as mass, or otherwise mass of the bullet over there. This is being multiplied by the velocity of the bullet. At which stage? On this side of the formula is at the final stage, which means you've got 80 over there. So obviously, this is where you now solve for m, where you apply your mathematical knowledge. You know you divide by 80. Why do you divide by 80? Is because you want that 80 to cancel so that you remain with mass, which is equals to what you do on the left, you do on the right. So 24 divided by 80, what is that? Guys, I thought you were punching it on a calculator, but otherwise it's 0.3 kg. So that means this is the mass of the bullet. So that means the mass of that bullet is equal to 0.3 kilograms. The mass of that bullet is 0.3 kilograms. Guys, this is how you score your marks. For this type of a problem, they are just going to give you a mark for correct formula, correct substitution, and again, correct final answer with the correct SI unit. So guys, I'm not sure if all of you understood that answer or an approach to solving that problem. Did you all understand, or is there something that you'd like for me to explain again? Let me see the momentum of the before it enters. Guys, I think I might have made a mistake somewhere. Let me see. The magnitude of the momentum of the bullet before it enters the block. I missed something very, very much important there. And I'm glad I was able to pick it up. So remember, guys, this momentum, it's a momentum before the bullet enters the block. So what does it mean? It means in place of that velocity, guys, are we going to use the velocity after or the velocity before? Let's firstly discuss that one before we conclude on that question. Which velocity are we using, guys? Guys, I'm not sure if we're still together. I'm not sure if the connection is poor on your side, but otherwise I'll just make an assumption that you are able to hear me and continue with this problem. So guys, because they are saying momentum of the bullet before is 24 kilograms meters per second, then we're going to say this is equals to the mass before multiplied by the velocity before, which is 480. I just want you guys to understand this part is because this given momentum is the momentum before. So that is the reason why there we substitute the value for the velocity before. So that means if we were given the mass of, the momentum of the bullet after, then we were going to use the velocity after. So that means we divide by 480 on both sides to say the mass is equals to, then it's going to be 24 divided by 480, which is equals to, let me see. So we're getting 24 divided by 480, and this is equals to 0.05. 0.05 kilograms. So that means the mass of that bullet is 0.05 kilograms. 0.05 kilograms, 0.05 kilograms. Still, guys, I'm not sure if we're still together. But otherwise, this is how you score your marks. 1 mark for the correct formula, 1 mark for a correct substitution, 1 mark for final answer. So it means there you say a B initial, because this is the momentum initial. You equate it to the values for the momentum initial. So ladies and gentlemen, that is how you score your marks for that question of 4.2.1. So now let's move to 4.2.2, where they say calculate the average net force exerted by the wooden block on the bullet. For the fact that they said the net force, that means your final answer must be a force is equals to something in Newton. And when you go to your formula sheet, you will see we've got a formula which says F net is equals to MA. And we know acceleration is actually the same as V final minus V initial over time. So this is being multiplied by that mass. Obviously, this is equals to force net. So I've just expanded that formula over there, ladies and gentlemen. So now, let's see. This can be equated to, it's just a matter of us substituting there, ladies and gentlemen. I'm not really sure if you are able to see what we'll be doing over there. But what is the mass? We just calculated the mass on the previous question, and the mass is equals to 0.05. Then there, let's substitute the velocity final. So guys, what is the velocity final of that bullet? This is where you are most likely to make a mistake. The question is that velocity final positive 80 or is it negative 80? Guys, are we still together there? Let me see. Nelin, who else? Lebohang, Dinos. Guys, are we still together there? I speak, or maybe if there's a disconnection or something. I'm not sure, guys.
Ga ke na problem ya connection and phone ka re ne dim jwa go bua ke fa ke mo tšatšing e sharp ndo.
Okay. The other guys, are we still together there?
Yes, sir, we are still together. And I think it's positive 80 because it's going in the eastward direction.
Okay. So, let me do this. Let me remove all of that and only remain with that question. I think let's see. The formula says F net is equals to mass times acceleration. So we already know the mass is 0.05. Let's substitute and say F net is equals to, in brackets is 0.05 multiplied by acceleration. So which means we now need to calculate the acceleration. And we know the initial velocity, we also know the final velocity, and again we know the time it takes for that bullet to pass through that wooden block. I think that velocity, let me check. Let's check on the question paper. What was that velocity? It was 0.01 seconds. So this is the time it takes for the bullet to pass through that wooden block. So we can then use equations of motion to calculate that acceleration over there. So the question is, which formulas for equations of motion can we use to calculate acceleration, where we know V final, we know V initial, we also know the time? So let me check the formula sheets. So there's that formula, guys, which says V final is equals to V initial plus acceleration multiplied by change in time. I'm not sure if you guys still remember this formula. But the same formula can be used. Why? Yes, because we know what the final velocity is, and again we know what the initial velocity is, and again acceleration is what we want, and we know what the time is. So remember, before we even get to this formula, I wrote somewhere to say acceleration is equals to V final minus V initial, all of this divided by time. Do you remember, guys? And I said the mass, I wrote the mass there, but we know the mass is that, into, then I said let's substitute. I had to remove everything so that I easily explain to you guys. So remember, the time we know, that is 0.01 seconds. But the tricky part is that on the V final, are we substituting a positive or a negative value? On the V initial, are we substituting a positive or a negative value? Remember, that is going to be substituted in brackets. Then you minus, which is that minus from the original formula. Then whatever sign you substitute in brackets over there. So my question is our V final there as substituted, is it being substituted as a positive or a negative value? Guys, is there someone who wants to guess that one? Okay, guys, so I'll just substitute it. So it becomes, for V final, you substitute it as positive 80. As positive 80. Why? It's because that bullet is still heading in the same direction. So we can make an assumption to say eastwards being positive. So that means initially it was moving eastwards, even after it's still moving eastwards. But if after hitting that wooden block, it made a U-turn and a move in that direction, which is westwards, we're going to substitute it as a negative value. So now that means our V final is 80 and our V initial is 480. Then you just punch the whole of that on a calculator. Someone to punch the whole of this on a calculator and let me know what answer are you getting. What are you getting, guys, when you punch all of that on a calculator?
Negative 40,000.
Anyone else? Nelin? I'm not sure of how you punched it on a calculator, but you must say into brackets 0.05, then you close, you open, you do a fraction button, then you say 80 minus 480, at the bottom is 0.01. Then when you say it's equals to, it gives negative 2000 Newton. So because of that negative, it means westwards, because we assumed eastwards to be positive. So it therefore means this is the same as 2000 Newton westwards. So that means the block is exerting 2000 Newton, which is the amount of the force, towards the bullet in that westward direction. So guys, this brings us to the end of our lesson for today. I'm not really sure if you all understood, and again, I'm not really sure if the network is 100% on your side, but I assume it all made sense to everyone. So this question was allocated 5 marks. Normally, for correct formula, they give you a mark. For correct substitution, they can also give you a mark. Then for correct answer with the correct direction, they also give you a mark. So ladies and gentlemen, This is how you would score yourself all the marks for that question. I think that question had 10 marks. So ladies and gentlemen, this brings us to the end of our lesson for today. So I'm just going to quickly stop recording.